In this video, we're going to be taking a look at an object that's suspended from a massless string that is leaning on an angle of 35 degrees because of the effect of the forces from this electric field that's applying a force of 6,000 newtons per coulomb. Now, our final solution that we're going to be looking for is a Q value, and also accurately identifying what sign that Q value is as well. So the first thing we want to do is analyze the forces acting on the mass. So we have the force of gravity pulling it straight down. We have the force of tension up from the string. And then we also have the electric force from the electric field as well. So we're going to write that in a second here. So for our Ft, as usual, if we have something angled, then we have an x component, which we'll call Ftx. And then we also have a y component, which we'll call Fty. Now, if the object is at rest, then we for sure know that all of the horizontal and vertical forces have to be canceling each other out. So I see two vertical forces, this purple one over here and this blue one right here, that seem to be canceling each other out. And we left the electric force out because maybe at first we weren't quite sure which way it was going, but it's definitely going to the right to cancel out this Ftx. So let's go ahead and sum up our forces along each of the axes. We have the sum of forces in the y direction, and we have Fty up minus the Fg down, and that equals 0, which would normally equal m times a, but there's definitely no a if the object is at rest. And then in the vertical direction, for the sum of forces in the x direction, we have our Fe minus our Ftx, and that definitely equals 0 newtons as well because the object is at rest. Now, we don't really have a whole lot to work with here, so a lot of people may get stuck with this problem because the only thing we really have is the 0.02 kilograms and the electric field of 6,000 newtons per coulomb. So as I'm looking at my setup here, I know I'm going to get my final answer right over here because our electric force equals Q times E. And I already have my E value, so once I have my electric force, I basically have my Q. So it's going to be a few steps to get there. So let's just go ahead and plug in what we know and see how we can eventually get there. So I know that I can find Fg because I have the mass. So I can go ahead and take the 0.02 kilograms and then multiply it by 9.8. Okay, now I put on the other side because if you add Fg to both sides, then it basically just flips over to the other side, and then Fty equals Fg, which is the 0.02 kilograms times 9.8, which means that Fty equals the product of those two numbers, which is 0.196 newtons. Okay, so the second thing we're going to do is anytime you have one side of a triangle along with an angle, then you can solve for any other part of it. So we do have a triangle set up here. I'm going to go ahead and redraw it off to the side. We have this angle of 35 degrees. And then we know that the y component is 0.196 newtons. And then we can go ahead and solve for the Ftx using our Fty. So we are interested in finding this. So in relation to this angle, we have the adjacent side and we're looking for the opposite side. So that means we're going to want to use tangent. So the tangent of 35 degrees equals the opposite side, which is Ftx, over the adjacent side, which is the 0.196 newtons. And then you can multiply both sides by 0.196, which is basically cross multiplying it over to the left. And then we have our Ftx value. Our Ftx value is rounded off to 0.14 newtons, which will be translated right over here. So we're going to add Ftx to both sides, which is going to send it over here. And that Ftx is 0.14 newtons, which equals our Fe. So now we're nearly there. We have a 0.14 Newton value for our Fe, which we can plug into this formula that I mentioned earlier. So we have 0.14 newtons equals Q times E. We are looking for Q, and we know our E is 6,000 newtons per coulomb. So if we go ahead and divide both sides by that 6,000 newtons, then Q equals 2.3 times 10 to the negative fifth coulombs. Now, the final thing we're going to do is, now that we found the magnitude of the charge, we want to make sure we get the sign right. Now, the electric field is pointing to the left, and then the electric force is counteracting that, going the different direction, which means that the Q value is negative, because the electric field lines are always based on how it affects a positive test charge. So if the force is being applied in the opposite direction, which it is, that means that your Q value is negative. So when setting up a question like this, always analyze the forces at first, sum up your forces along each of the axes, and then plug in a little bit at a time. If you find a number such as this that is part of your triangle, you can always use a little bit of trig to find other parts of your triangle, which led us to find the Fe. And then once we found the Fe, we can send that equal to QE. We already had the E value of 6,000. So once we set that up and divided both sides by 6,000, then we got our final Q value of negative 2.3 times 10 to the negative fifth coulombs. And we knew that was negative, again, because that force was going against the field lines. So I hope that was helpful to you. Thank you for watching and listening.